What do you know about the weather?
Sometimes it's sunny,
and sometimes it's cloudy,
and when it's cloudy, sometimes it rains.
or snows.
Ah, yes, precipitation. Rain, snow, sleet, and hail. A fine topic for our weather-watching kids from around the world. Learning about the weather is just like learning about anything else. You have to investigate. Are you ready? Okay then, let's go. Before we can understand precipitation, we need to know just what makes weather in the first place. You really just need 3 simple ingredients: air, sunshine, and water.
Sounds like nice weather to me.
Ah, but there's more to it than that. Weather changes when the sun heats air and water, or when air and water that have already been heated cool off. It sounds simple, but this is really what creates all the different kinds of weather in the world, from clear skies to driving rains and even fierce blizzards. Here's how it works. The air we're talking about is called the atmosphere, and it surrounds the entire Earth like a protective blanket.
So when we breathe, we are really breathing in the atmosphere?
Yep, that's one reason why it's so important. If there were no atmosphere, we would have no air to breathe. Step outside and look up. That's the atmosphere. The air that is always moving above and all around you. And even though it's invisible, that air has weight. Here's an easy way to see that air really does have weight. All you need is a string, a meter stick, and 6 balloons. First, tie the string around the middle of the meter stick so it balances when you hang the stick from the string. Perfect. Now tape 3 of the balloons to each end of the stick and see if it still balances. Of course it does. The balloons weigh the same on each end of the stick. Now let's add some air. Take the 3 balloons from one end of the stick and blow them up nice and big. Now tape them back to the end of the stick. Hold up the string and see if they still balance. Give it a moment. Look at that! Now the end with the blown up balloons is sinking. That means those balloons are now heavier than the others. And all we added was air. But just look up and imagine all the air there is above you. Miles of air. So much air, in fact, that added all together, the average weight of the air pressing on just one little square inch of your body is almost 7 kilograms. That's about 15 pounds. The weight of the atmosphere pressing on us is called air pressure. The entire surface of our planet is covered by air. Mountains, oceans, deserts, even the North and South poles. So now we know the role air plays in shaping the weather. But what about the next ingredient?
Sunshine!
Not only is sunshine a key ingredient in making weather, but without the sun, there would be no life on Earth at all. Heat energy from sunlight is what warms the Earth. Sunlight grows our plants, and of course, lets us see where we're going. When sunlight hits the Earth, it warms the ground. If you've ever tried to walk across hot concrete or the sand on a beach, you know how that works. When the ground gets warm, the air above the ground heats up too. As it does, the air gets lighter and floats upward. Other air rushes in from the sides to take its place.
Rushing air sounds like wind.
That's right. Air moving sideways is wind, and wind is part of weather. Okay, the time has come for our final ingredient. We've got air and sunshine. Now we only need
Water!
And we've got plenty of water here on Earth. Like air and sunshine, we need water to survive. In fact, all living things are made of mostly water. People spend most of their time on land, so it may seem like the Earth is mostly covered by dry land. But really, it's just the opposite. Most of the Earth's surface, about 75%, is covered by water in the form of oceans, lakes, and rivers. In fact, the Earth is often called the water planet.
But how does the water end up falling from the sky?
Once again, it has to do with the sun. Remember that sunlight heats up the ground. The same thing happens when sunlight hits water. The water gets warmer, and when water heats up, it can turn from a liquid into a gas, called water vapor. This process is called evaporation.
So the sun warms the liquid water on the earth, and that puts water vapor into the air.
And when the water falls back to the earth, that's precipitation.
Exactly. Precipitation is really that simple. But let's take a closer look. The process of water turning into water vapor, becoming part of the air and falling back to the ground, is critical to life here on Earth. And it's happening all over the world, all the time. It's called the water cycle. And here's how it works. There are 3 steps in the water cycle. The first step we already talked about, evaporation.
That's when liquid water turns into water vapor in the air.
Bingo. And when warm air rises high up in the sky, it cools. As the air cools, the invisible water vapor begins to turn back into a liquid. This is step 2, condensation. It's easy to see condensation in action. When you see water on the windows of your bathroom after a hot shower, that's condensation. Or when water collects on the outside of a cold drink on a hot day, that's condensation too. In both cases, water vapor in the air hits the cold glass, cools down, and turns back into water droplets. Water vapor is invisible, but when condensation occurs high up in the sky, the water vapor in the air appears right before our eyes as clouds.
So clouds are made of water.
Absolutely. Clouds form when water vapor in the atmosphere cools down, starts to collect on invisible dust particles in the air, and turns into tiny water droplets. If the air cools enough, and if there's enough water vapor, the water droplets get bigger and heavier. When the water droplets in a cloud get too heavy to stay in the air, they fall back to Earth in step 3 of the water cycle, what you've all been waiting for.
Precipitation!
Ah yes, precipitation. Rain, snow, sleet, and hail. Water falls to the Earth, where it is once again ready to be heated by the sun and evaporated into the air. Ladies and gentlemen, I give you the water cycle. A never-ending process of evaporation, condensation, and precipitation. Did you know that most of the Earth's water is salty ocean water that we can't drink? Luckily, when water evaporates from the oceans, the salt is left behind. Wind blows the fresh moisture in the air from over the oceans to over the land, where it falls as fresh water in the form of rain, snow, or ice. Ladies and gentlemen, boys and girls, welcome to another heavenly edition of Why Air Rises.
So first things first, why does air rise in the first place?
Well, there are a couple of reasons to answer that question. Reason number 1, air rises where the land rises. Rising air is the key to forming clouds. If the land slopes upward, like near a mountain, winds blowing across the land all move up the side of the mountain. That's why there are so many clouds and so much precipitation near mountains. Reason number 2, warm air is lighter than cool air. And remember, warm air usually has more moisture in it than cooler air. The air heats up, rises, and forms clouds as it cools. Eventually, the clouds can get big enough to produce rain. Reason number 3, air moves away from areas of high pressure toward areas of low pressure. That's wind. When winds blow toward low pressure, they meet and have nowhere to go but up. And reason number 4. Air rises when huge masses of warm and cold air run into each other. When this happens, the warmer air always rises up over the cooler air. And there you have it. Be sure to tune in again for another exciting episode of Why Air Rises. So warm air is lighter than cool air, and that makes it rise. Here's an easy way to see how it works. You'll need a meter stick, some string, and 2 paper plates. Tape one plate to each end of the stick, facing down. Now check to make sure that the string is in the middle and that the stick balances. There you go. The plates weigh the same, so they balance out. Now you'll need a heat source. A light bulb in a lamp should do fine. Make sure an adult helps out here. Now hang the meter stick from the string so that one of the plates is directly above the light bulb. Be careful not to actually touch the light. Now give it a few seconds and watch what happens. Look at that! The end of the stick that's over the lamp is rising up. We know that the plates in the stick are perfectly balanced. How does this happen? The answer is that warm air is lighter, so it rises. The light bulb is hot, and that heats the air around it. That air becomes lighter and begins to rise. That rising air pushes the plate and lifts that end of the stick. As air moves, it heats and cools. Sometimes we can see the results, and sometimes the result is precipitation. Rain, snow, sleet, and hail. What kind of precipitation falls depends mainly on the temperature of the air, and not just near the ground, but all the way up into the clouds. When liquid water falls from the sky, we all know what kind of precipitation that is.
Rain!
No doubt about it. Rain is what cancels our picnics, turns dirt into mud, and chases us indoors. But rain has its good points, too. In fact, rain is our main source of fresh water on the planet. Rainwater fills lakes, ponds, and rivers. It seeps into the ground and supplies water for wells and springs. It keeps plants green and fresh, the ground soft and moist. How rain happens might seem simple, and it really is. In fact, we've already explained it. Let's review.
Warm, moist air rises high up in the atmosphere.
The higher it rises, the cooler it gets, causing the water vapor to condense. This forms clouds.
Clouds are made of lots of tiny water droplets. When the water droplets get too heavy to stay up in the air, they fall back down to the earth as rain.
An excellent recap. But many times the water droplets in a cloud get so cold that the water droplets turn to ice. When the ice falls, the warmer air closer to the ground makes it melt on the way down. Just think about it. The rain you feel on the ground may have started out high in the sky as ice. Usually when it's raining out, we know the air temperature near the ground is above freezing. But sometimes during the winter months, a thin layer of really cold air is near the ground, and raindrops fall through it without freezing. When these chilly raindrops land, they immediately freeze, covering whatever they've landed on with a smooth sheet of ice. This is called freezing rain, and it can be very dangerous, making any surface as slippery as a skating rink. Knowing how much rain actually falls is important to meteorologists, the scientists who study the weather. Meet Dr. John Neese. He's the chief meteorologist at the Franklin Institute Science Museum in Philadelphia, Pennsylvania.
It's so important to have a measurement of how much rain falls, and for that, meteorologists use a rain gauge. We measure rainfall by simply placing a ruler down into the cylinder, holding the ruler there for a couple seconds to let some of the water grab on to the ruler, and then we lift the ruler out and see how high the water level reached. Well, knowing how much it rains is important simply because it helps us estimate how much water will make its way into streams and creeks and rivers, and also how much water will make its way into reservoirs. So it's helpful to know for the next day or several days or weeks how much rain actually falls. Well, weather controls so many aspects of our life. What we wear, when we decide to go outside and play, and when we have to stay inside. And observations help us determine the answers to those questions. Weather observations are probably most important when the weather turns severe or extreme. When a large amount of rain falls in a very short time, flash flooding often results. Water starts ponding on roads, making some of them impassable. Streams and creeks start rising and overflowing their banks. Even rivers can rise quickly and flood neighboring roads and houses. Well, the opposite of flooding would be drought, not enough rain. In a drought, plants start to wither. Water levels may go down. In the most extreme cases of drought, farmers can lose their entire crops, and the land can be so dry that fires start more easily.
Of course, freezing rain isn't the only form of precipitation that can make your walk to school a bit slippery. In some places, the air near the ground is cold enough that frozen water droplets don't melt as they fall. They stay frozen as tiny ice crystals. These crystals combine and fall to the ground as
Snow!
Yep, snow joke. A snowflake is really a bunch of tiny ice crystals frozen together. They say that no two are exactly the same. But one thing is for sure, when they pile up on the ground, they can cause some real problems. And some real fun. Places with cold winters can get huge amounts of snow each year. Some places get very cold and are near water. A snow-making double whammy. This combination can add up to huge amounts of snowfall. Some mountains in the western United States throw another factor into the mix. At the tops of some of these peaks, it not only gets very cold during the winter, but blasts of moist air coming from the nearby Pacific Ocean aid in the snowmaking. That constant supply of water vapor results in an average of more than 17 meters of snow per year in some areas. That's over 56 feet. The same thing happens at other places in the world too, like the Alps in Europe and the Himalayan mountains in Asia. Moist air from nearby oceans means lots of snow. But there are some cold places that don't get much snow at all. Take the South Pole, for example. Temperatures there are way below freezing all year round, but it hardly snows. Any ideas why not?
Well, it's definitely cold enough. It must be because there's not enough moisture in the air.
Absolutely right. Because it stays so cold all year, very little water evaporates. So the air stays very dry, so that what little snow and ice that does fall there hardly ever melts. Measuring snowfall isn't as easy as you might think. Because the snow settles as soon as it lands, and because the wind tends to blow snow around, measurements are taken in several places to get an average depth. And think about this. If you melt this much snow, you'd only be left with this much water. Think about that the next time you get 2 inches of rain in a day.
That's a lot of snow if the air was cold enough.
Besides rain and snow, there are also a few other forms of precipitation. Sometimes the air near the ground is cold, and the air up near the cloud is cold, but there's a layer of warmer air between them. When this happens, snowflakes fall from the cloud and start to melt when they hit the warmer air. When those tiny melted snowflakes hit the colder air near the ground, they refreeze, turning into tiny pellets of ice. This precipitation is called
Sleet!
When sleet hits the ground, the ice pellets usually don't stick to things, they bounce. If enough sleet falls, it can pile up and make walking and driving pretty tricky. One of the craziest forms of precipitation is hail. Hail reaches the ground as balls of ice called hailstones that can be smaller than a pea or as large as a softball.
Ouch! I wouldn't want to get hit by that.
Luckily, hailstones that big are pretty rare. Hail can cause lots of damage to cars, windows, and yes, to people. What's amazing is that hail almost always falls during the spring and summer, when it's warm near the ground, above freezing anyway.
How do balls of ice fall to the ground when the air temperature is warm?
Well, it takes some wild weather to make hail happen. Thunderstorms, in fact. Way up high in a storm cloud, tiny bits of ice can form and start to fall. But sometimes, strong updrafts of air can blow the ice bits back up into the cloud. As they fly through the cloud, these specks of ice pick up more and more moisture, which freezes and makes them larger, becoming small hailstones. The more times the pieces of ice are lifted back into the cloud, the bigger the hailstones get. Eventually, they become too heavy and they fall to the ground. When that happens, it's time to take cover. Let's do a final check on what you've learned about precipitation. Any volunteers?
Precipitation is water falling from the clouds to the ground.
Sometimes the water is frozen solid, like in snow, sleet, or hail, and sometimes it falls as liquid.
That's rain.
Precipitation always comes from water that has evaporated into the air and formed clouds.
It's part of the water cycle: evaporation, condensation, and precipitation.
The water cycle keeps the earth supplied with fresh water to grow our plants, to keep our rivers and streams moving,
And to drink.
I couldn't have said it better myself. Our atmosphere has water in all its forms: ice, water, and water vapor. Sometimes they're all in the same cloud. And sometimes that water falls back to the earth. That's what makes weather so much fun.